This edition of SpaceTime is brought to you by Audible.com. Get a free audiobook download and a 30-day free trial at www.audibletrial.com/spacetime. Over 180,000 titles to choose from for your iPhone, Android, Kindle, or your MP3 player. That's audibletrial.com/spacetime for your free audiobook. This is SpaceTime Series 20, Episode 10, for broadcast on the 3rd of February 2017. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, discovery of the most extreme blazars ever seen, new evidence supporting the idea that we live in a holographic universe, and planet Earth survives another asteroid near miss. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Fermi Gamma-ray Space Telescope has just discovered the most distant blazars ever seen. Blazars are powerful jets composed of particles and energy travelling at close to the speed of light. They're produced by supermassive black holes feeding in the centres of galaxies. The new findings, reported in the astrophysical journal Letters, indicate the light from the most distant of these newly detected objects began its journey towards us when the universe was only 1.4 billion years old, just a tenth of its current age. One of the study's authors, Rupesh Wah from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says despite their youth, the 5 blazars detected appear to originate from some of the biggest supermassive black holes ever seen. The fact that such huge black holes were able to develop so early in cosmic history challenges current ideas of how supermassive black holes form and grow. Blazars constitute roughly half of all gamma-ray sources being detected by NASA's Earth-orbiting Fermi Large Area Telescope. Their high-energy emissions are powered by matter falling into a black hole. You see, as matter falls in, it forms an accretion disk just beyond the black hole's event horizon, a sort of point of no return. Think of the accretion disk as sort of being analogous to water swirling around the sink's plug hole before finally going down the drain. Material on the accretion disk is ripped, crushed, and torn apart at the subatomic level. A small part of all this infalling material spills out and is guided by powerful magnetic fields into 2 energy beams which jet out perpendicular to the black hole's accretion disk. The remaining material then passes through the event horizon to fall forever into the black hole's singularity. When one of the jets happens to point directly towards us, the blazar will appear bright right across the electromagnetic spectrum, including in gamma rays, the highest energy light. The previous most distant blazars detected by Fermi emitted their light when the universe was about 2.1 billion years old. The earlier observations also showed that the most distant blazars appear to produce most of their light at energies right between the range detected by Fermi in gamma rays and the range detected by X-ray telescopes. That made finding them extremely difficult. Then in 2015, the Fermi team released a full reprocessing of all their data, which they call Pass 8. This ushered in so many improvements, astronomers began comparing it to having a brand new instrument. It especially boosted sensitivity at lower energies, increasing the chances of finding more distant blazars. The research team began by hunting for the most distant sources in a catalogue of 1.4 million quasars, a class closely related to blazars. Because only the brightest sources can be detected at great cosmic distances, they then eliminated all but the brightest objects at radio wavelengths from the list. With a final sample of about 1,100 objects, the authors then examined the Fermi data for all of them, resulting in the detection of the 5 new gamma-ray blazars. Expressed in terms of redshift, astronomers' preferred measure for objects in the deep cosmos, the new blazars range from a redshift of 3.3 to 4.31, which means the light we now detect coming from them was generated when the universe was just 1.9 to 1.4 billion years old. Once they found these sources, the authors collected all the available multi-wavelength data on them in order to determine what they could about the supermassive black holes that generated them. That data includes as much as they can find out about their mass, their accretion disk luminosity, and the power of their jets. To the amazement of the authors, two of the blazars boasted black holes more than 1 billion times the mass of the Sun. Now, by comparison, the supermassive black hole at the centre of our own galaxy, the Milky Way, is only about 4 million times the Sun's mass. All 5 of the blazars they examined possess extremely luminous accretion disks, emitting more than 2 trillion times the energy output of our Sun. This means matter is continually falling inwards, corralled onto the disk and heated before making the final plunge into the black hole. The main question now is how these huge black holes could have formed in such a young universe. The authors are now searching for more of these ancient monsters to help them better understand the process. Scientists want to understand the types of mechanisms that could have triggered such rapid development. In the meantime, the team plan to continue a deep search for additional blazars. They think Fermi's only detected the very tip of the iceberg, simply the first samples of a galaxy population which previously had not been detected in gamma rays. I'm Stuart Gary. This is SpaceTime. A new study has provided what researchers believe could be the first observational evidence that the universe really is a vast, complex hologram. Physicists investigating irregularities in the cosmic microwave background radiation claim they've found as much evidence supporting a holographic explanation for the universe as what there is for the traditional explanation for these irregularities, using the theory of cosmic inflation. The cosmic microwave background radiation is the faint afterglow from the Big Bang 13.8 billion years ago. It pervades the entire sky in all directions and is now cooled to just 2.7 degrees above absolute zero. Slight variations in that temperature represent the ancient signatures of density variations in the very early universe, just 370,000 years after the Big Bang, a time when the cosmos had finally cooled enough to allow subatomic particles to come together in the primordial quark-gluon plasma, forming the very first protons and allowing photons to escape. This cosmic microwave background radiation can be easily detected. It's part of the white noise responsible for the black and white dots you see on an untuned TV set. The hypothesis of a holographic universe was first suggested back in the 1990s. The idea is that all of the information which makes up our three-dimensional reality, plus that fourth dimension of time, is actually contained on a two-dimensional surface on the universe's boundaries. The new findings have been published in the journal Physical Review Letters. One of the new study's authors, Professor Kostas Skenderis from the University of Southampton, says it's actually very similar to that of ordinary holograms, where a three-dimensional image is encoded onto a two-dimensional surface, such as the hologram on a credit card. However, in this case, the entire universe is encoded. He says it's a bit like imagining that everything you see, hear and feel in 3 dimensions, together with your perception of time, actually emanates from a flat two-dimensional field. Skenderis says, although not an example with holographic properties, it could be thought of as watching a 3-dimensional movie. The viewers see the pictures as having height, width and crucially depth, when in fact everything they're seeing is actually originating on a flat 2-dimensional screen. According to Skenderis, the difference is that in our 3-dimensional universe we really can touch objects and the projection is real from our perspective. In recent decades, advances in telescopes and sensing equipment have allowed scientists to detect a vast amount of data hidden in the cosmic microwave background, left over from the time the universe was created. Using this information, Skenderis and colleagues were able to make complex comparisons between networks of features in the data and quantum field theory. They found that some of the very simplest quantum field theories would be enough to explain nearly all cosmological observations in the early universe. Skenderis describes holography as a huge leap forward in the way scientists can think about the structure and creation of the universe. You see, Albert Einstein's general theory of relativity explains gravity in the large-scale structure of the universe. The problem is it starts to unravel when examining the origins and mechanisms of the cosmos at the subatomic or quantum level. So scientists have been working for decades to try and unify Albert Einstein's general theory of relativity, the theory of gravity, with quantum mechanics. Some researchers believe the concept of a holographic universe has the potential to reconcile the two, and Skenderis thinks his team's research could take scientists another step towards that goal. In fact, he believes the research could eventually open the door to further science's understanding of the early universe and even explain how space and time merged. Speaking of space-time, that's what you're listening to now. I'm Stuart Gary. Okay, let's take a break from the show and talk about one of our sponsors. Audible's offering a free audiobook download with a 30-day trial to give you an opportunity to check out their service. Audible have over 180,000 different titles to choose from, such as Contact by Carl Sagan or A Brief History in Time by Stephen Hawking. Others include the unabridged version of The Hobbit by R.R. Tolkien, Divergent by Veronica Roth, and Born to Run by Bruce Springsteen. So many great books no matter what your taste. Over 180,000 titles to choose from. To download your free audiobook today, go to audibletrial.com/spacetime. That's audibletrial.com/spacetime for your free audiobook. Or you can click on the link at spacetimewithstuartgary.com. And now, back to our show. Those of you who keep an eye on our SpaceTime blog on Tumblr will know that potentially hazardous asteroids are constantly zooming past the Earth. In fact, we seem to be reporting 1 or 2 NEOs or near-Earth object asteroids every day. But of course it's the ones we don't see which keep astronomers and emergency services awake at night. And so this is one of those uncomfortable scenarios. We report that astronomers have detected another relatively large asteroid that almost sped past the Earth completely unnoticed. The space rock, designated 2017 AG13, passed the Earth at a distance of less than 200,000 kilometres, about halfway between the Earth and the Moon. The asteroid's travelling at almost 16 kilometres per second, and it's estimated to be up to 34 metres wide. 2017 AG13 was discovered by the University of Arizona's Asteroid Hunting Catalina Sky Survey on Saturday. Early orbital trajectories indicate it's on a 347 Earth-day elliptical orbit around the Sun, ranging from a perigee, or closest orbital position to the Sun, of about 82 million kilometres, and going out to an apogee, or most distant orbital position from the Sun, of around 204 million kilometres. Based on that velocity, and depending on its composition and mass, had it hit the Earth, 2017 AG13 would have exploded with the force of a 700 kiloton nuclear bomb. That's some 35 times more powerful than the bomb dropped on Hiroshima to help end World War II. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
They kind of caught sight of this one more or less after the fact. It was upon us before we could have even contemplated doing anything about it. Not that we can at the moment, but it happened and caught everyone off guard.
That's right, Andrew. It's the whole industry, which is what it is now, of discovering near-Earth objects, as they're called, asteroids that might one day present a threat to the Earth. That is very much a process that involves specific telescopes looking at the sky, using the modern technology to check for objects that are moving through the sky, and then very quickly calculating whether this is an object that is likely to hit the Earth. That is all done automatically. There are a number of telescopes which have been doing that. There is a project which is on Maui that is specifically looking for near-Earth objects. These telescopes are basically able to see objects which are now considered relatively small. Remember, when it comes to asteroid impacts, it's the big ones that are the dangerous ones. Mm-hmm. And the rule of thumb is that something 100 meters across, if it hits the Earth, has the same explosive power as a 100 megaton nuclear weapon. And that's big time stuff. So a 100-meter object, it's kind of football field size, that could wipe out a city easily. Now, it's these sorts of objects that the cameras are looking for, and there are several of them that are tuned to do that. And one of them, on actually almost the first weekend of January, of the first weekend of the year, spotted an object passing by the Earth, half the distance of the Moon. It was basically pretty well at its nearest distance by the time it was seen. It was detected by something called the Catalina Sky Survey, which is actually based near Tucson in Arizona, traveling at 16 kilometers per second, which is typical speed for an asteroid. This one was about 30 meters across.
Okay, so that's getting kind of big.
It's getting kind of big. That's right.
Yeah.
It's about twice the size of the object that hit the skies of Russia back in 2013. You probably remember that in February 2013, a huge fireball appeared above the town of Chelyabinsk, which is in Russia. It exploded with a brightness 30 times the brightness of the sun. It was about 30 kilometers above the Earth when it exploded.
And thanks to the litigious nature of Russian drivers, we got a lot of footage from dash cams.
That's right, all the dashboard cameras. And that's how scientists were able to work out its trajectory and deduce that this thing came from the main asteroid belt.
And it caused a lot of damage. It shattered lots of windows. There were injuries. Thankfully, no deaths, but it gave you a really good insight into what one of these things could do. So this one's bigger.
Yes, that's right. So you're quite right. The Chelyabinsk event, because it lit up the sky, it basically had people running to their windows to see what was causing this. And then a couple of minutes later, the shockwave from the explosion reached the ground and smashed most of the windows probably in the town. I think 1,200 people wound up in hospital because of that. But as you say, there was no loss of life. And bits of the object were recovered because some of it made it down to Earth. Some of it landed actually in a frozen lake nearby. Yes, this object seen at the beginning of January this year is bigger than that. It is likely to have done rather more damage if it hit the Earth. We, however, I think can take some solace from this story. And the solace is that, yes, it was detected. Even though it was almost upon us when it was detected, it was found. And that is something that 30 years ago wouldn't have happened, even though these things were whizzing by us in space at the same rate as they are now back then.
So if it, let's just say this was the one that hit Earth and exploded over Chelyabinsk, what would have happened to the town then?
I think it would have done much more damage. It depends on the structure of the asteroid as to whether it explodes in the atmosphere. In other words, the forces that are generated when it's superheated through its passage through the atmosphere, if those forces are enough to overcome the structural integrity of the object, then it'll blow itself to pieces, as did the Chelyabinsk object. And then you get a fireball in the atmosphere. Now, we've got a model for what happens with that, actually for a much larger object, probably something 50 to 70 meters across. And that is the Tunguska Event.
Yes.
And this is something that happened in 1908 over the Siberian forest. That basically flattened trees for something like 2,000 square kilometers. That was a bigger object than the one we've just missed. But the bottom line is that it's somewhere between those two extremes. If you imagine a 30-meter object, that's probably going to cause an explosion that, if it happened over a city, would do significant damage and probably cause significant loss of life.
They tend to compare these things with the bombs that were dropped at the end of World War II over Nagasaki and Hiroshima.
That's correct. And that's about the sort of level.
And they're suggesting this one was like, if it had hit the planet, would have been much, much more powerful than Nagasaki.
Yes, that's correct. And that's basically because of the mass of the object. What it's all about, Andrew, is what we call the kinetic energy. This particular one over Chelyabinsk came in at about 30 kilometers per second. And that's very typical. And it's that velocity that actually imparts the energy that you can measure in megatons or kilotons. So this particular asteroid, it's suggested that it might be 30 times more than the Nagasaki bomb in terms of its explosive power.
Wow.
So it's a significant event, absolutely.
Yeah, it's pretty scary, but we're getting better at finding these things. This one sort of got too close too soon before we spotted it, but yeah, as you say, we did spot it. So that's a plus.
It is a plus, yeah. It is a plus. Just as a footnote to that, there was a White House document that was produced at the end of last year, which is a really good up-to-date summary of where we're at with the discovery of these near-Earth objects and, what facilities are in place to do the detection. I do believe, as I said, it's a good news story. We were in blissful ignorance of all this only a few decades ago.
Yeah. Well, for hundreds and hundreds of years, we stood around on this planet not even knowing that this was a possibility. So I guess that's just blind luck. But here we are now in a position where, well, ultimately we might be able to do something about it one day.
Exactly. That's right.
Or at least prepare and say, OK, we need to evacuate all of southeastern Australia. Start moving now.
Better get moving now. That's right. It's I mean, that would be the last ditch response is civil defence measures.
Yeah.
There has been an argument mounted that there should be a spacecraft that is actually ready to tackle this problem, because it takes typically 5 years to get a space mission ready. And you might not have that length of time if you do discover something that has a big threat. At the moment, by the way, all known asteroids taken together, there is no significant threat for the next 100 years. So
yeah, it's the ones we don't know about.
It's the ones we don't know about, that's
But we'll
correct.
keep an eye out for them.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. It's been revealed Iran has conducted a ballistic missile test in another violation of United Nations Security Council resolutions. The flight, which occurred on Sunday, was designed to test a new re-entry vehicle warhead fitted to a ballistic missile. The 12-metre-long two-stage Khorramshahr was launched from the Semnan military base 220 kilometres east of Tehran. Reports from the United States military claim the test resulted in the failure of the re-entry vehicle, which exploded about 1,000 kilometres into the flight during its re-entry phase. The secret Iranian test was detected by US surveillance satellites designed to monitor missile launches by their heat signatures during the launch and ascent phase of the flight. Iran claims the Khorramshahr is a new generation of high-precision missile, which only went into production in 2016. Its production was announced at the same time as two other new long-range missiles were announced by Tehran, the other two using solid fuel propellants. It appears to be based on the North Korean BM-25 or Hwasong-10 ballistic missile, 19 of which were reportedly transferred from Pyongyang to Tehran as part of a nuclear weapons and missile technology research and development agreement between the two rogue nations. If the Khorramshahr is the BM-25, it has a range of up to 4,000 kilometres and is specifically designed to carry a 1 megaton thermonuclear warhead. It's based on the Soviet Union-era R-27 Zub marine-launched ballistic missile, which uses a hypergolic combination of unsymmetrical dimethylhydrazine fuel and nitrogen tetroxide oxidizer for propellant. Pyongyang's already successfully test-fired the missile in a ground-launch configuration. The test violates United Nations Security Council Resolution 2231, which prohibits Iran from carrying out ballistic missile tests as part of Tehran's agreement to stop developing atomic weapons and the missiles needed to deliver them. UN Resolution 2231 went into effect on the 20th of July 2015. It was put in place just days after the Iran nuclear deal was signed with the Obama administration. It specifically prohibits the Islamic Republic from carrying out ballistic missile tests involving nuclear-capable missiles for a period of 8 years. This latest violation is the second by Tehran of its agreement. A similar test was conducted last July. It's also the first violation since US President Donald Trump took office, and it's being widely seen as Tehran testing the new US administration's resolve to strictly implement the nuclear accord and other restrictions on Tehran related to missile development and its support of terrorism. For years prior to this agreement, Tehran refused to allow unfettered access to United Nations International Atomic Energy Agency inspectors to visit and examine suspected Iranian nuclear weapon sites, claiming the oil-rich republic's nuclear program was for peaceful power generation only. Arianespace has launched a Russian Soyuz rocket from the European Space Agency's Kourou spaceport in French Guiana, carrying a new type of telecommunications satellite into orbit.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Et décollage VS16.
And they are off. Hispasat 36 W1. The European Space Agency's first ever small geo platform has begun its journey. Soyuz is hauling itself against the pull of our planet. The boosters are doing all the work at the moment. They're delivering 80% of the thrust right now.
Les paramètres propulsifs sont conformes à l'attendu.
He's telling us that the propulsion is as expected. So the booster's job is to get us away from Earth. We need a lot of firepower to do that. Soyuz is heading out east over the Atlantic, and that's a first for the Soyuz vehicle here at the Guiana Space Center. It's the first time it's headed east. Usually it goes west
Tous les
or
paramètres à bord
north.
sont normaux.
He's telling us everything's normal. Everything's going according to plan.
The early morning launch lit up the black tropical skies with a golden ribbon of fire as Spain's Hispasat 36W1 satellite was lifted into geostationary orbit aboard the Soviet-era Russian rocket. Arianespace Flight VS-16 was the first Soyuz R-7-based rocket launched from Kourou into a geostationary orbit. The rocket's single main RD-108A and four strap-on RD-107A kerosene and liquid oxygen-fueled engines combined to power the flight for the first 2 minutes of the mission, before the strap-ons were jettisoned, leaving the core stage to continue powering the stack till main engine cut-off or MECO some 4 minutes and 45 seconds after launch.
Our altitude there, 43 kilometers above the Earth, and this is the scheduled moment for separation of the boosters.
Des blocs BVGD.
They twist and turn as they fall of the way. So we're now burning the main core stage, which is now called the second stage, or Block A.
Stabilisation correcte du lanceur après séparation.
Everything's going well.
The Soyuz upper stage, which is hot staged while still attached to the core, then ignited for a 5-minute burn of its single RD-0124 kerosene and liquid oxygen-fueled engine. Hot staging is a common practice used by the Russians to allow stage separation to occur without the need of special rockets to push one stage away from the other. Once the Soyuz upper stage had completed its burn, the Frigate MT stage then ignited its nitrogen tetroxide and unsymmetrical dimethylhydrazine S5.92 engine for a 19-minute burn to bring the satellite payload into its geostationary transfer orbit. The 3-ton satellite was then released by the Frigate MT into its transfer orbit 29 minutes after liftoff. Using its own onboard thrusters, the satellite then made its way to its final geostationary orbital position 36,000 kilometres above the equator over the Atlantic Ocean, from where it'll provide broadband services to Europe, South America and the Canary Islands. Based on Europe's new small GEO platform, the Hispasat 36W1 is designed to provide a flexible modular telecommunications platform. Hispasat 36W1 uses an advanced reconfigurable antenna and onboard processor to allow greater flexibility and signal quality. The flight was the first launch for Arianespace's 2017 manifest. Its next mission will see the launch of 2 communication satellites on an Ariane 5 rocket slated for February the 14th. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGarry.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.